Once upon a time, people were very frustrated with exponential functions because with exponential functions, your domain element, or your x, is, by definition, stuck up in the exponent, and it's really hard to solve this type of function. So a new family of functions was invented, and these functions were called logarithms. Now, before we get into studying these families closely, it's worthwhile to go through just a few properties of logarithms that we need to memorize because they behave a little bit different than usual. So watch the patterns carefully here. Log base b of m times n equals log base b of m plus log base b of n. Essentially, if you have the log of two things that are multiplied, that can turn into two logs of things that are added. Next, log base b of m divided by n becomes log base b of m minus log base b of n. Notice that division kind of turns into subtraction when you take the log of each term. Lastly, we have log base b of x to the second power, but this could really be any number in the exponent, and that equals 2 times the log base b of x. So this property of logs allows us to get an exponent out of its exponent position and into a regular real number position in the expression. Now, this log that you see is short for logarithm, and the little b is the base. Don't worry about the bases now, just notice that they sort of carry along with the logs. If you don't see a b, it has an automatic base of 10, but you might see this other term, and it looks like ln. See where I've written in red? That's a script L and a script lowercase n. This is called the natural log, and we see it often, and we see log logs kind of often, so it's worthwhile taking a glance at them. It works just like log logs. The natural log of m times n equals the natural log of m plus the natural log of n. The natural log of m divided by n equals the natural log of m minus the natural log of n. And the natural log of x squared would equal 2 times the natural log of x. You need to get comfortable working with these log properties because they're going to be important when we go to solve exponential and log equations.